With this video, we're going to be looking at linear sequences and determining how do we actually work out the rule if we're given a set of numbers. So before we go through what an arithmetic or how to actually do that, we need to understand that these are actually what we call arithmetic sequences. So if something is a linear sequence, we call it an arithmetic sequence. And arithmetic sequences are number patterns that increase or decrease by a constant. Or in other words, there's the same sort of pattern going on with a sequence. So for example, if I gave you the numbers 2, 4, 6, 8, 10, you can see as we're going up each term, we're increasing the value by 2. So in other words, the increase is constant because each term is increasing by 2. So the key thing with working out if whether or not a sequence of numbers is linear is to check the first differences between each consecutive number. So what that means is that if I was given a sequence, so you can see here 2, 4, 6, 8, what I need to do is just check what was the difference between 2 and 4? Well, we worked out the difference between 2 and 4 is 2. The difference between 4 and 6 is 2. The difference between 6 and 8 is 2. And the difference between 8 and 10 is 2. So we've checked something that we call the first differences between each consecutive number. So the fact that this number here is a 2, this number here is a 2, the first difference is a 2, it actually shows that it is an arithmetic sequence in that case. So let's look at an example from this. So let's just say you were given a sequence of the numbers 2, 4, 6, 8, 10. So that was the example that we looked at. The first thing you will need to do is to check the first difference. And the reason why we do that is to check whether or not it is going up by a constant number, or if it's being increased by a constant number. So you can see here, the difference between 2 and 4 is 2. The difference between 6 and 4 is 2. The difference between 8 and 6 is 2. And 10 and 8 is 2. So then we can then apply the next few steps to work out the actual rule for this sequence. So what we can say is that this rule is going to be 2n. The reason why I say 2n is because that is the change in each sequential pattern. So whatever number you'll get here, the first difference, will be the number that you tack on to the n. So what I'd like you to do now is have a think about, well, if I've written 2n here, and I substitute 1 is equal to here, so we get 2 times 1, the value we'll get for this particular entry will be 2. The next thing is, I want you to think about, if I put the 2 into 2n, what I end up getting is 2 times 2, which is equal to 4. So this particular entry will be 4. And likewise with the next one, 2n, if I substitute 3 into there, what I end up getting is 6. And you can try the other ones, but believe me, the next ones will be 8, and the next ones will be 10. So the reason why I've done this is because I wanted to check whether or not my particular sequence right here gave me the original sequence that I was given. So in this case, is there a difference between the 2 and the 2? No, there is a 0 difference. So this is supposed to note down the difference. So now, is there a difference between the 4 and the 4 that we were given? Well, the difference was 0. Next one, this, there. So that means that becomes that, and that is that. So what we end up having is that I can then conclude that my rule will be 2n. Because what I ended up calculating was that if I put in 2n to the equation, I get exactly the same sequence in return. So the rule for that one is 2n. Now let's have a look at another case where that might not be so evident. So you can see with this one, there is still a pattern that's going on. So the first difference is 2, second difference is 2, first difference, sorry, is 2, and the first difference is 2. So since the rate or the change that's happening from each pattern is 2 and it's constant, I can say that the base will be 2n. So now I'm going to quickly calculate this 2n value. So 2 times 1 will be 2. 2 times 2 will be 4. 3 times 2 will be 6. 8, and then 10. So the reason why I've done this is, again, I need to check what is the difference between the sequence that I've got with 2n. Well, to get from 2 to 4, I would need to plus 2. So to get from 2 to 4, I need to plus 2. So we'll follow on with the rest of this to double check to make sure that there is a constant pattern going on. So to get from 4 to 6, I need to plus 2. To get from 6 to 8, I need to plus 2. To get from 8 to 10, I need to plus 2. So it seems like all the differences here are plus 2. So then I can then combine these two things that I've just calculated and then say therefore the rule for this is 2n plus 2. Now it's important to check whether or not you have done this right or not. So let's just say for n equals 2. For n equals 2, what value do we get? Well, let's try the rule out. So 2 brackets 2 plus 2. So 2 times 2 is 4 plus 2, or in other words, 6. And does the second n term give us 6? Yes. Therefore, this is right. So let's look at another example. So with this example, we're given another sequence. You can see there is a negative number there, but don't be afraid because we just need to do exactly the same thing that we've been doing. So what is the difference between minus 3 and 2? Well, we have to plus 5. What's the difference between 2 and 7? 5. Difference between 7 and 12, 5, and 5. So therefore, we have just shown that this is an arithmetic sequence because there is a constant difference between each successive term. So then I can say 5n. Now, my job is to work out what is 5n going to be for each of these n values. So 5 times 1 will be 5. 5 times 2 will be 10. 5 times 3 will be 15. 5 times 4, 20, and 25. Now this one is a bit tricky now. So my question is, how do we get from 5 to a minus 3? Or in other words, what's the difference between 5 and minus 3? In this case, the difference would be, I do apologize guys, what I'm trying to say here is we need to work out what is the difference between minus 3 and 5. So how do we make 5 turn into minus 3? We have to take away 8. So now, if I asked you what is the next number going to be, how do I make 10 turn into a 2? Or in other words, what I'm asking is, what is the difference between 2 and 10? Well, it's minus 8. And again, you'll see this one's minus 8, minus 8, minus 8. So therefore, what we can do is combine these two and say 5n minus 8. Now, just with all things that we calculate, it's best to check whether or not it holds with the sequence. So let's check n equals 2. So if we check n equals 2, what we end up having is 5 times 2 minus 8. Or 5 times 2 is 10 minus 8. That equals 2. Does that give us the original sequence? Yep. Therefore, we have come up with the right rule. Now the last one is, you can oftentimes come across decreasing sequences. Or, in this case, you can see there are decimals as well. So let's find the rule for this. So again, what is the difference between 30 and 29.5? We have to take away 0.5. What is the difference between 29.5 and that? We have to take away 0.5, take away 0.5, and then take away 0.5. Or in other words, the thing I'm going to put here is minus 0.5n. Now we just need to calculate what is it going to be if I plug this in. So 1 times minus 0.5 will give me minus 0.5. The next one will give me minus 1. The next one will be minus 1.5. Next one is minus 2. Next one will be minus 2.5. So now, here is where this question is actually a bit more tricky. What is the difference between 30 and minus 0.5? Or in other words, how do I get from minus 0.5 to 30? Well, I'll have to add 30.5 because if I add 30.5 and minus 0.5, I end up getting 30, which gives me that. So the next one, how do I get from minus 1 to 29.5? Or in other words, what is 29.5 take away minus 1? That will give us plus 30.5. Next one will be plus 30.5. Next one is plus 30.5. So you can probably already guess what the rule is going to be. We're going to say the rule is minus 0.5n plus 30.5. So again, good habits, check. Let's try n equals 2. Let's see what n equals 2 will give us. So if we plug in n equals 2 to this, so minus 0.5 times 2 plus 30.5. So 2 times 0.5 will give us, negative 0.5, sorry, will give us minus 1 plus 30, or minus 1 plus 30 will give us minus 30.5, sorry, will give us minus 29.5. And so since that, sorry, I do apologize, that's plus 29.5. Since that gives us 29.5 and this is 29.5, therefore our rule is correct. So what I'd like you to do now is consider the questions that I've put here. With question 1, just follow the patterns. Make sure you set your tables out as I have in this question or this video. And if you can, have a think about number 2 and make sure that you justify your reasoning with this question.